In this video, we're going to go through the worked out solutions for the Unit 8 review. This includes both polynomials and radicals, or in other words, square roots. Alright, so number 1 says write g of x in standard form. G of x is right here. Standard form means I need the highest exponent first and then descending exponent. So that would be g of x is equal to 2x to the third minus 8x squared minus 42x. The degree in this case is the highest exponent. That would be 3. The leading coefficient would be 2, this number out front here when it's written in standard form. And then to classify it, I need two terms. I need to first classify it by its degree. The degree is 3, so this is a cubic function. And because there are 3 terms, I know it is a trinomial. So this is a cubic trinomial. It also wants me to write j of x in standard form. Well, j of x is 5 plus x, so I need to write the x term first and then the plus 5. The degree is the highest exponent, and I know that's x to the first power, so it's a degree of 1. The leading coefficient is the number out front. That also happens to be 1 because we don't see anything. So to classify this, I first classify it by its degree. Its degree is 1, so this is a linear function, or sometimes we can see that's in y equals mx plus b form, and we recognize it's linear from that. And then I also classify by its number of terms. So there's 2 terms, so this is a binomial. So we call this a linear binomial. Now it wants us to factor h of x. When directions say factor, I know my answer is going to look like the factors multiplied together. So sometimes parentheses, sometimes not. So h of x, I'm going to start with it in standard form, and it makes it easier to factor. My first step in factoring is to factor out the GCF. When I do that, I recognize that the GCF of 8 and 2 is going to be 2, so I'll put a 2 out here. This has 3 x's, this has 2, so I can factor out an x squared. So 2x squared times 4x gives me the 8x to the third. 2x squared times a negative 1 gives me a negative 2x squared. So h of x is equal to 2x squared times 4x minus 1. And in the parentheses, I have to look and see, can I factor this any further? I look at the degree. This is a degree 1, meaning this is a linear factor. If it's a linear factor and I've already factored out the GCF, I cannot factor it any further. So I am finished right here. Now g of x, I'm going to factor that. Again, I'm going to start with it in standard form. So we have 2x to the third minus 8x squared minus 42x. Well, I want to factor out the GCF. I look at these 3 terms, and they are all even, so they're all divisible by 2. I have x to the third, x squared, and an x, which means they all have an x that I have, or that I can factor out. So the GCF is 2x. When I factor out, we'll see what we're left with. 2x times x squared gives me the 2x to the third. 2x times a negative 4x gives me negative 8x. And 2x times a negative, 21 gives me negative 42x. So g of x is equal to 2x times the quantity x squared minus 4x minus 21. Now this time, what is left over in the parentheses once I factor out the GCF is quadratic. Because it's quadratic, I can try and factor. So the first way I start factoring quadratic functions would be to find the product sum. 2 things that multiply to be negative 21 and add to be negative 4. Well, I know I multiply to be negative, so I need 1 positive, 1 negative. And I add to be a negative, so the larger number will have to be a negative. So I believe that is negative 7 and a positive 3. Because my a value is 1, I do not need to do the box. I can jump right to my factors. I'll have the 2x as my GCF, and then my x minus 7, x plus 3. And because both of those, well, I guess all 3 of these factors are all linear, they cannot be factored any further. Alright, so getting down to the next one. I want to find the zeros of the function. Well, zeros is really just another way of saying x-intercepts, which means I know we need to let y equals 0. And in this case, y is really h of x. So I have 0 equals, now I could start with this guy in standard form, but eventually I'm going to have to factor it to find the 0. So let's just go ahead and use the one factored form we already have. Because it's in factored form, or it's written as a product of its factors, I can use the 0 product property. I set each factor equal to 0. 2x squared equals 0, 4x minus 1 equals 0. I can divide both sides by 2, and then take the square root, and I get x equals 0 as one solution. I can add 1 to both sides and then divide by 4 and get x equals 1/4 as the other solution. And if we wanted to write it as x-intercepts, we'd write 0, 0, and 1/4, comma 0. For g of x, again, I could start with standard form, but I already factored it, so let's start with the factored form. I substitute 0 in for g of x. And now, because it's in factored form, I can set each factor equal to 0, to x equals 0, x minus 7 equals 0, and x plus 3 equals 0. When I divide both sides by 2, I get x equals 0. When I add 7 to both sides, I get x equals 7. And when I subtract 3, I get x equals negative 3. And again, if I wanted to write those in ordered pairs, I could write it like that. Scooting on to the next one, the directions say, perform the indicated operation. Write your answer in standard form. So all of our answers have to be in standard form. Then identify the degree, the leading coefficient, and classify it by its number of terms and the degree. Okay, we got a lot of things that are going on here. Number 7, we are adding h of x and g of x. Well, h of x was 8x to the third minus 2x squared. G of x was negative 42x plus 2x to the third minus 8x squared. We just need to combine like terms when we add. So I have 8x to the third and a positive 2x to the third. Those will add to be 10x to the third. I move on to my x squared items. Negative 2x squared and a negative 8x squared would be minus 10x squared. And now my x term is just minus 42x. Because we're writing them in descending order with the exponents, that's already standard form. It also wants to identify the degree, the leading coefficient, and classify it by its number of terms and degree. So the degree is 3. The leading coefficient would be 10. And because it's a degree of 3, it is a cubic. And because there's 3 terms, it is a cubic trinomial. Scooting over here, h of x minus g of x. So now we're subtracting these. So this would be 8x to the third minus 2x squared. That's our h of x minus g of x, negative 42x plus 2x to the third minus 8x squared. I have to distribute that negative. Think of that as like a negative 1. You're subtracting each of those terms. So we have 8x to the third minus 2x squared plus 42x minus 2x to the third plus 8x squared. And now from here we combine like terms. It becomes like an addition problem. 8x to the third minus 2x to the third is a 6x to the third. Negative 2x squared plus 8x squared is now plus 6x squared. And then we have our x term plus 42x. The degree is 3. The leading coefficient is 6. And to classify it, it is a cubic trinomial. Moving on to number 9, j of x times g of x. Well, j of x is 5 plus x, and g of x is negative 42x plus 2x to the third minus 8x squared. Now, I do think this will be a little bit easier if we wrote both of these in standard form, so let's rewrite this. X plus 5 times 2x to the third minus 8x squared minus 42x. We've talked about multiple ways to do this. You can use the distributive property and just write it in a row, or you can use the distributive property by doing the area model. I'm going to do this with the area model because I just think it's easier to organize all of my terms. So I'm going to do my x plus 5 over here, 2x to the third minus 8x squared minus 42x. So when I do that, I get 2x to the fourth minus 8x to the third minus 42x squared. 5 times 2x to the third would be 10x to the third. 5 times negative 8x squared would be minus 40x squared. And 5 times negative 42x would be a negative 210x. From here, I combine like terms. There's only one term that's x to the fourth, so I have 2x to the fourth. I have 2 terms that are x to the third plus 2x to the third. I have these two terms that are x squared minus 82x squared. And then I only have one x term minus 210x. And there is the expression in standard form. We forgot to box that in. We'll go ahead and box that in. There we go. All right, so then it says identify the degree. The degree is the highest exponent in this case, which is 4. The leading coefficient would be 2. And then to classify it, because the degree is 4, it is a quartic. And because there's 4 terms, anything more than 3, we just say polynomial. The quartic polynomial. Over here, we have to square g of x. Well, g of x is really 2x to the third minus 8x squared minus 42x. Written in standard form just makes it a little easier as we move forward. And I need to recognize that when I square a polynomial, really anything more than a monomial, I need to write it times itself. So that's really, if I use my area model, we'll have 2x to the third minus 8x squared minus 42x times 2x to the third minus 8x squared minus 42x. And now we have to multiply each of these terms. So this is going to be a 3 by 3, or 9 terms we're going to have to multiply together. Here I get a 4x to the 6th minus 16x to the 5th minus 84x to the 4th, negative 16x to the 5th plus 64x to the 4th plus 336x to the 3rd, and then minus 84x to the 4th plus 336x to the 3rd, and then our last two terms multiply to be a positive 1,764x squared. Holy smokes. All right, so those are only one x to the 6th term, so we're going to write that as 4x to the 6th. I'm going to add my x to the 5th terms. That's minus 32x to the 5th. And now all my x to the 4th terms. That'll give me minus 104x to the 4th. My x to the 3rd terms gives me plus 672x to the 3rd. And then finally my x squared terms. And let's see if we can squeeze that in. 1,764x squared. That is my final answer. All right. So the degree is 6. Leading coefficient, 4. If I were to classify this by the degree and the number of terms, because it's a degree 6, we just say degree 6. Because there's 1, 2, 3, 4, 5 terms. Anything more than 3, we just say a polynomial. And there we go. All right, moving on to the next page. It says a rectangle has a base of x plus 4 and a height of 4x squared minus 10. Write an expression in standard form for the area of the rectangle. Well, let's draw a picture so we understand what's going on. So we have x plus 7 and 4x minus 10. And we want an expression for the area. Remember, area is equal to base times height. Well, that means that area will equal x plus 7 times 4x squared minus 10. We've talked about multiple ways to do this. You can use the area model, or you can use the distributive property, which some of you guys use the acronym FOIL. So since we've been using the area model for the other problems, let's use distributive property or FOIL here. So we have to multiply the first terms. It would be 4x to the 3rd. The outer terms, minus 10x. The inner, plus 28x squared. And the last, minus 70. And then from here, we have to combine like terms. Well, to be honest, there are no like terms to combine. They're all different terms. So we just need to make sure we write this in standard form. So the area is equal to 4x to the 3rd. The next highest exponent would be x squared. The next would be the x and minus 70. And that is the expression for the area in standard form. Now it says write an expression in standard form for the perimeter of the rectangle. It says recall, perimeter is the distance around the rectangle. So, excuse me, if we look at this rectangle again, this is 4x squared minus 10. Here is our x plus 7. This side over here is also 4x squared minus 10. and this side is also x plus 7. So when we do perimeter, we can start in one spot, and we kind of just walk all the way around. So if I'm doing the perimeter, I add this side, 4x squared minus 10, plus x plus 7, plus 4x squared minus 10, plus x plus 7. And from here, I can combine like terms. So all my x squared terms, I have 4x squared plus 4x squared gives me an 8x squared. My x terms, x plus x gives me plus 2x. And then now I add all the constant terms. So negative 10 plus 7 is a negative 3. Negative 3 plus a negative 10 is a negative 13. And plus 7 is a negative 6. So this would be the expression for the perimeter. Now sometimes people like to memorize a formula, and they remember that perimeter is equal to 2 times the length plus 2 times the width, or 2 times the base plus 2 times the height for a rectangle. So you could do that as well. 2 times 4x squared minus 10 plus 2 times x plus 7. Here we would just distribute first, so the perimeter would equal 8x squared minus 20 plus 2x plus 14. But then when we simplify these, you still get 8x squared plus 2x minus 6. So either way, we'll still get the same answer. All right, moving on to number 12. Directions for number 12 and 13 say factor completely. So we just need to remember our steps for factoring. Our very first step is to factor out the greatest common factor. The greatest common factor of 8 and 128 is going to be 8. The GCF of y to the 5th and y to the 3rd, because y to the 5th has 1, 2, 3, 4, 5 y's, and y to the 3rd has 1, 2, 3. The most they have in common is 3. So the GCF would be 8y to the 3rd. And in parentheses, we'll go whatever is left over once we factor out the GCF. So 8y to the 3rd times what is 8y to the 5th? Well, we already got the 8, but we're going to need the 2 other y's to make that y to the 5th. And then 8 times what is negative 128? Well, if I'm not sure, I can always grab my calculator and I can type in 128 divided by 8, and that gives me 16. Okay, so I know it's minus 16. Now I always have to check to see if I can factor further. When I look inside the parentheses, because this is quadratic, we have a y squared, I could potentially factor further. And I'm going to see if I can factor it by doing my product sum. I need two things that multiply to be a times c. In this case, a is 1 and c is negative 16. So multiply to be negative 16 and add to be b. Well, I don't see a y, so I need to add to be 0. That will end up being 4 and negative 4. So because a is 1, I don't have to do the box. I can skip right to my factors. Y plus 4, y minus 4. And because these are two linear factors, I am all set. Can't go any further. All right, looking at the next one. The GCF here, well, the only thing that they have in common is an x. So I have x and then parentheses. X times 6x squared will give me the 6x to the 3rd. X times a positive 11x will give me 11x squared. And x times a negative 35 will give me the negative 35x. And now, because this is quadratic, I continue to factor if I can. I need two things that multiply to be a times c, or negative 210. And I need two things that add to be b, or 11. And I recognize that would be 21 and a negative 10. Now, because the a value is not equal to 1, I have to do either factor by grouping with the area model of the box, or I have to do factor by grouping in a row. So I'm going to do it with a box. The first term goes in the first spot, the last term goes in the last spot, and then I take my two product sum numbers and I throw in an x with them because they have to add to be that 11x. So now I cover up the bottom. The GCF of these two, what does that look like? 2x. 2x times 3x gives me 6x squared. 2x times a negative 5 gives me negative 10x. The GCF of these two is 7. 7 times 3x is 21x. 7 times negative 5 is negative 35, so I check that. So now to write my final answer, I bring the x down. One factor would be my 2x plus 7. The other factor, 3x minus 5. I don't need a y equals or f of x equals because we started with an expression, so we're going to end with an expression. Scooching down here to number 14, it says solve the equation, and I know when the directions say solve, my answer will look like x equals y equals, or in this case, b equals. So, in order to solve this, I first need to make sure it's equal to 0. In this case, it is. So we have 3b to the third plus 2b squared minus b equals 0. And my first step to solve is to factor this and then use the zero product property. First step in factoring is to find the GCF. And the GCF in this case is b. b times 3b squared gives me 3b to the third. b times 2b gives me 2b squared. And b times a negative 1 gives me the negative b. So the first step in factoring is done. The second step in factoring is to look inside the parentheses and see, can I factor it further? Because this is quadratic, I might be able to factor using the product sum. Two things that multiply to be a times c are negative 3, and two things that add to be b. That would end up being a 3 and a negative 1. Because the leading coefficient, or the a value in this expression, is not equal to 1, I have to use I have to do factor by grouping. So I have a 3b squared and a negative 1. I take these two terms and throw a b in there with them. And when I factor out the GCF in this top row, I get just b. b times 3b gives me 3b squared, and b times negative 1 gives me a negative 1b. The GCF here is just 1, and I double check this. 1 times 3b is 3b, 1 times negative 1 is negative 1. So we're good there. So I take down the GCF, and then I have my other two factors. And that's still all equal to 0. So now it's factored and equal to 0. And because it's all factored and equal to 0, I can now use a zero product property. I set each factor equal to 0 and solve. Well, b equals 0, that's already solved. I subtract 1 from both sides and get b equals negative 1. I add 1 to both sides and then divide by 3 and get b equals 1/3. And those are all the solutions to the equation. Over here it says find the zeros of the function. We talked earlier that the zeros mean this x intercepts, or to let y equal 0, or in this case f of x equals 0. So 0 equals 5x to the fourth plus 25x to the third. So my first step is to start factoring now that it's already set equal to 0. I factor by first finding the GCF. The GCF, both of these are divisible by 5, and because this is an x to the fourth and that's x to the third, 1, 2, 3, 4 x's, and 1, 2, 3 x's, the most they have in common is x to the third. 5x to the third times x is 5x to the fourth. 5x to the third times a positive 5 is 25x to the third. So I have 0 equals 5x to the third times the quantity x plus 5. I look in here, and because that's a linear factor, I do not have to continue factoring, rather, it's just ready to go. So I have 5x to the third equals 0 and x plus 5 equals 0 using my zero product property. I can divide both sides by 5 and I get x to the third equals 0. So now I'm thinking, well, what can I multiply by itself 3 times and get 0? The only thing that x could be is 0. Here, if I subtract 5 from both sides, I get x equals negative 5. And there are my two zeros of the function. Or you can write them as 0, 0, negative 5, comma 0. All right, moving on to the next one. We're going to start some simplifying expressions. And I see a lot of radicals, so we're going to simplify these square roots. Our answers have to be left in simplified radical form. So this first one, I'm going to simplify the square root of 32 using the factor tree. I know that that's 4 times 8, or 2 times 2, that's 4 times 2, that's 2 times 2. So here are all my prime factors. I know that that's the square root then of 1, 2, 3, 4, 5 2's multiplied together. So that's the square root of 2 squared times 2 squared times 2. Well, the square root of 2 squared is 2, square root of 2 squared is 2, and then we have the square root of 2 left over. Or in other words, this would be 4 times the square root of 2. The other way to do it is to say, what is the perfect square? So square root of 32, the largest perfect square that square root of 32 is divisible by would be 16. So that's square root of 16 times the square root of 2. The square root of 16 is 4, and then I carry down that square root of 2. Either way, I get that the square root of 32 can be simplified to 4 times the square root of 2. Now I have to think through the m's, or m to the fifth. So m to the fifth, I can think of that as 1, 2, 3, 4, 5 m's multiplied together. I'm going to group these into perfect squares. That's the square root of m squared times m squared times m. Well, square root of m squared is just m. Square root of m squared is m. Square root of m I have to leave under there. Or in other words, I get m squared times the square root of m. And then if I combine here, I have a 4 and then 2 underneath the square root. So my final answer is 4m squared times the square root of m. Looking over here, there's a couple different ways we can do this. We could multiply these together first and then do a factor tree, or we could simplify them first and then multiply together at the end. So I'm going to do it by simplifying first. I'm going to do this with the perfect square method. The largest perfect square that 12 is divisible by is 4. So that's really the square root of 4 times the square root of 3. So this would really be 2 times the square root of 3. You could get that just as easily doing the factor tree. And over here, the largest perfect square that 63 is divisible by is 9. So that's square root of 9 times the square root of 7, or 3 times the square root of 7. And now I can multiply these two together. 2 times 3 is 6. Square root of 3 times square root of 7 is square root of 21. And I have to check to see if I can simplify this further. 21, there's no perfect square that 21 is divisible by. And if I do the factor tree for it, it's just 3 times 7. So that's not going to end up simplifying any further. There's my final answer. For number 18, again, I can either multiply them together first and then simplify it, or simplify each of them separately, then multiply. Since we simplified first and then multiplied, I'm going to do it the opposite order here. This becomes the square root of, I multiply the two radicands, 50 times 18, and I get 900. Now again, I can do this two different ways. I can see what's the largest perfect square that 900 is divisible by, and that would be 100. Well, no, it's not. 900 is a perfect square. Square root of 900 is 30. So, we're done. Now, if I didn't know that, I could do my factor tree and just say, okay, that's 9 times 100, that's 3 times 3, 10 times 10, 5 times 2, and 5 times 2. And I have all my prime factors. So this is the square root of 3 times 3, 5 times 5, 2 times 2. If I group these into perfect squares, I notice they're all perfect squares. That's the square root of 3 squared times 5 squared times 2 squared. Square root of 3 squared is 3. Square root of 5 squared is 5. Square root of 2 squared is 2. So when I multiply these all together, 5 times 3 is 15 times 2 is 30. And I still get the same answer. All right, scooching down. For number 19, 2 times the square root of a to the 4th, b to the 5th. Well, the only thing I have to simplify is what's underneath here. So that would be 2 times the square root of, we have 1, 2, 3, 4 a's, 1, 2, 3, 4, 5 b's. And I can only take the square root of perfect squares. So I'm going to group these into perfect squares. So this is 2 times the square root of a squared times b squared times b squared times b squared times b. So that's the square root of a squared, square root of a squared, square root of b squared, square root of b squared, square root of b. Square root of a squared is just a, square root of a squared is just a, square root of b squared is just b, square root of b squared is b. Square root of b, I have to leave that under the square root because b is not a perfect square right now. So 2 times a times b will end up being 2a squared, b squared, square root of b. Now in class we talked about shorter ways to do this. We noticed a pattern that if it was an even number, it would just end up being half of that if you take the square root. So that's a squared. And if it's an odd, we could think of this as b to the 4th times b. So then half of the 4 would be b squared, and then that b just stays left over. If you want to do it this way and write it all out, you can do that as well. All right, so looking over here, we can go ahead and multiply them together first, or simplify and then multiply. I'm going to multiply them together first. So that's the square root of 10 times 35 would be 350. X squared times x to the 5th is x to the 7th. So now I'm going to simplify the square root of 350. I don't know what perfect square 350 is divisible by right away off the top of my head, so I'm just going to break this down into a factor tree. 7 times 5, that's 5 times 2. So now I have the square root of 5 times 5 times 7 times 2, or the square root of 5 squared times 7 times 2. So if I simplify that, square root of 5 squared is 5. That's going to be out of the square root. But the 7 and the 2, the square root of those will be irrational because they're not being squared. So that's going to be the square root of 14. Now let's think about the x to the 7th. The square root of x to the 7th would be 1, 2, 3, 4, 5, 6, 7 x's. And if I group them into perfect squares, that would be the square root of x squared times x squared times x squared times x. Square root of x squared is x, square root of x squared is x, square root of x squared is x, and then this square root of x just stays like that because it's not a perfect square. Or this is x to the 3rd times the square root of x. So the x to the 3rd is outside of the square root. Not second, x to the 3rd. And then the x is underneath with the 14. And here's my final answer. So your number here to number 21. Again, I can multiply the 2 times, well, that's like a 1, so I'm just going to keep it as a 2. The square root of 16m squared, and then n times n will give me n squared. Now, the square root of 16 is just 4. Square root of m squared is m. Square root of n squared is n. So I'm really just multiplying all these together. 2 times 4 is 8 times m times n. There's my final answer. Let's get down to number 22. Now we're adding and subtracting. So to simplify these, I remember that can only add and subtract radicals that have the same radicand. And notice that this is square root of 3, square root of 3, square root of 3. I can add all of these terms. So I add the numbers out front and I keep the square root. So square root of 15 times the square root of 3 plus 20 times the square root of 3 would be 35 times the square root of 3. And I'm still going to subtract that square root of 3. So that's like a 1 here. So it's like 35 minus 1 is a 34 times the square root of 3 as my final answer. Looking over here, notice they don't have the same radicand yet. So I need to simplify this to see if I can get the same thing. So the square root of 175, I know that 75 is divisible by 25. 25 times 7, so that's 5 times 5. Or the square root of 5 squared times 7, or 5 root 7. So this is 15 times the square root of 7 minus 5 times the square root of 7. So now it becomes like the previous problem. 15 minus 5 is 10, and then we have the square root of 7. Kind of like when we had 15x minus 5x, it was just 10x. Same idea. So over here, we have all different radicands. So let's try and simplify this if we can. First of all, square root of 9 is just 3, plus 9 times the square root of 8. Well, let's simplify square root of 8. Square root of 8, the largest perfect square that 8 is divisible by is 4. So I can write that as 2 root 2 if we use the perfect square method. Or you could use the factor 2 method if you prefer. So this is 9 times 2 times the square root of 2 minus 6 plus square root of 2 we cannot simplify because 2 is a prime number. So now we really have that that's 45 plus, this will be 18 square root of 2, because 9 times 2 is 18, minus 6 plus the square root of 2. So 45 minus 6 will give me a 39. 18 times the square root of 2 plus square root of 2 will give me plus 19 square root of 2. And that's my final answer. I cannot combine these because this guy has a square root and this one doesn't. So I cannot combine them any further. All right, moving on. Now, solving equations. And we're solving square root equations. So remember, whenever we're solving square root equations, first our answer is going to look like x equals. But we always have to check our answers because we know that sometimes we can have extraneous solutions. So when I look at this and I only see a single square root, I'm going to isolate that radical. I'm going to do that by subtracting 12 from both sides. I get 4 times the square root of x minus 7 is equal to 16. Now I'm going to divide by 4 because this is 4 times the square root and those are inverse operations. Those divide to be 1, so I'm left with square root of x minus 7 equals 4. And now the inverse of square rooting something is squaring it. So I square both sides and I get x minus 7 is equal to 16. I add 7 to both sides, I get x is equal to 23. Now before I box that in as my answer, I have to check it. And I always check in the very, very beginning, the original equation. So 4 times the square root of 23 minus 7 plus 12 equals 28. I could put that whole thing in my calculator or I can simplify it by hand. If I simplify it by hand, I simplify that first. So 4 times the square root of 16. I want to know, does that equal 28? Well, square root of 16 is just 4. 4 times 4 is 16. and we get 28 equals 28. That works. That is a solution. Over here, the square root's already isolated, so now I just square both sides. I get 6 minus x equals x squared. Now I have a quadratic equation. I have an x squared and an x. Because there's an x squared and an x, I recognize that I need to write this in standard form. I'm going to move everything to the right-hand side so that I have a leading coefficient that's positive 1. So I'm going to subtract 6 and add x. So I'm going to write this now in standard form. These add to be 0. I have 0 equals x squared plus x minus 6. So now I try and solve this. I'm going to first try to solve by factoring because it's in standard form. I need two things that multiply to be negative 6 and add to be 1. I believe that's a positive 3 and a negative 2. Because the leading coefficient's 1, or the a value is 1, I can jump right to factored form. And now I set each factor equal to 0 and solve. I get x equals negative 3 and x equals 2. And again, before I box in my answers, I always have to check. So we're going to check both of these in the original equation. So the square root of negative 6 minus negative 3, we want to know, does that equal negative 3? We put in that negative 3 anywhere we see an x. Well, that's the square root of 9. We want to know, does that equal negative 3? Well, that's 3 equals negative 3. That is not true. That means that x equals negative 3 is an extraneous solution. All right, we got to check the other one too, though, because sometimes neither one of them work. We don't know, is this true? Well, that's the square root of 4. Square root of 4 is 2. 2 does equal 2, so we only have one solution here. Switching down to this next one, now I have two square roots. When we see an equation that has two radicals and they're set equal to each other, I can square both sides. And I get x minus 7 equals x plus 21. And now I need to solve. So these are linear. I don't have an x squared anywhere, so I'm going to subtract the x's to get them on the same side. But when I do that, they both add to be 0, and I have negative 7 equals a positive 21, and x is gone. But those are not equal to each other. So this is a case where we have no solution. There is no value for x that would satisfy that equation. Finally, over here, we see just one square root, so we're going to isolate the square root by subtracting 5 from both sides. Square root of 5x is equal to negative 5. I square both sides. I get 5x is equal to a positive 25. Divide by 5, I get x equals 5. Again, we always have to check our answers. So I substitute back into the original equation. The square root of 5 times 5 plus 5, we want to know, does that equal 0? Well, that's the square root of 25, or 5 plus 5. We want to know, does that equal 0? Well, it doesn't. 10 does not equal 0. So that is an extraneous solution as well. And we can recognize, because we have the square root equal to a negative back here, which is square root, unless we have the negative out front, won't ever be equal to a negative. So this one is also no solution. All right, and moving on to the last page. Got to focus on some graphing now. Here it says choose the graph that models the function and then find the domain and range of the function. All right, so I see this plus 1 at the end. I know that translates it up 1 unit. So when I look at these graphs, that one went up. Yeah, that looks like it went up 1. This went up 1. This went down 1. And this went down 1 as well. So those two won't work. Now the difference is this one is opening up. This one was reflected. Because there's not a negative out front, I know it's not reflected, so A must be the correct graph. The domain is my possible x values, and x goes from 0 all the way to the right, so x is greater than or equal to 0. The range, well, that's my y values. My lowest y value will be 1, and then it goes up above that, so it's y greater than or equal to 1. Moving down here, I see a plus 3 inside, which means I know it's going to the left 3 units. It's not reflected, so it's going to be opening like this. So this one went to the right. That's not going to be the right answer. This one went to the left. Okay, that's possible. This one went to the left, also possible. That one went to the right. But we said because there's no negative, it's going to be going up like that. So B is the correct answer here. In this case, the domain, we look at the x values, we're to the left 3, so the lowest x value is negative 3. It's anything to the right of that, so x greater than or equal to negative 3. The range is the y values. The lowest y value is 0. and then it goes up, so y greater than or equal to 0. And then moving down here, our last problem, which function matches the graph? So now we are given the graph and we've got to decide which one of these. So I look at this point right here. This is a crucial point. I know that I went to the right 5 and down 5. So right 5 and down 5. Well, to go down 5, I know I need a minus 5 on the outside. So this one won't work, nor will this one. And to go right 5, I need a minus 5 on the inside as well. So B is the correct answer. And now we are finished with the Unit 8 review.